Okay, today's topic is I will give one examples to explain what's the difference between infinitively many and except for finitely many, and it's their relationship. Okay, let's consider two circles. I am, uh, I am, I am, and from one to infinity, and bn, and from one to infinity. And today I'm going to introduce these two things. There is infinitely many and except for finitely many. Okay. Let's see these two sequences. And an, what's the an? An is the sequence 1 minus 1, 1 minus 1, 1 minus 1, and so on. And let's write it more clearly. That is am is equals to 1 when n equals to 2k minus 1, k from 1 to infinity, right? And an equals to minus 1 when n equals to 2k, k from 1 to infinity. That's the sequence of an. Let's consider bn. What's bn is? What's bn look like? It is minus 1, minus 1. Let's add the comma, minus 1, and go on, many, minus 1, and the first, and the first 1 billion. Okay, let's write it clearly. That is bn equals to minus 1 when n less and equal to 1 billion, less and equal to 1 billion, and bn is equal to 1 for else n. Okay, that is greater than 1 billion. Okay, let's see these two circles. Okay, that is here. I'll make it small. Okay, and like that. Okay. Okay, let's see it. And we say it. And the question is how many one is in the sequence, are there in the sequence. Okay, earlier in the sequence. That's the question I want to ask. Okay, that's for an. For an, how many? That is, we have infinitely, we have infinitely many a one, because we can see it's when and when the n can be divided by 2, it can't be divided by 2, an equals to 1, and this kind of n goes to infinity, so there are infinitely many an is equal to 1. So for the sequence of an, there are infinitely many 1 appear. Okay, and for bn, we also have infinitely many 1, right? Because when bn goes to infinity, all bn equals to 1. And although there are also many minus 1 in this sequence, but it is finite. No matter it is million, billion, or something like this, it is finite. But and the sequence goes to infinity, so we also have infinity many 1 for bn. Okay, that's the first expression of infinity. That is this one. There is 6 infinitely many. Both sequence an and bn satisfy this kind of thing. And let's consider this one. Okay, that is for all except for infinity many. For an, we don't have for all except for finitely many. One, however, for bn, it does. Let's see it. When we say about an, this sequence, although it has infinitely many 1 appear to an, whence it cannot be divided by 2, but we also have infinitely many minus 1. So we cannot say that we have all the an which is equal to 1 except for finitely many things, because although we have infinitely many 1, we also have infinitely many -1. But look at the sequence of Bn. Look at this sequence. Though we have many -1, but we have 1 billion -1, but they are finite. They are finite, so we can say that this sequence Bn, it has for all except for finitely many thing, that is, except for the finite thing which is equals to -1. So these two things we can infer from these two examples that they are different, but they have relation. What's the relationship between them? If we say that for all except for infinitely many, we can say there is 6 infinitely many. But we can say the vice versa. We can say that there is 6 infinitely many, and then for most all. We can't do like that. This is correct. However, this direction is wrong. That's the relationship between them, and we can get it from these examples. All right, that's all for today. Thank you.